Hello, it's Mrs. Wagner here. I am going to be filming the Unit 2, Lesson 1. This is Activity 3. So this is dealing with the different sized cylinders. So when we look at our interactive notebook, we're going to be on slide 8 and 9. Okay, so we'll get started here in just a sec. Okay, so on slide 8, it's going to give us the directions on how to do this lab. So this is a mass volume relationship. We're going to need a massing scale. We will need some graduated cylinders, or a graduated cylinder right there, and then some cylinders. And so I've got 5 different sized cylinders, but all of the same material, okay? And we actually have a bunch of different of the samples of these. So here's another example of 5 different sized cylinders, but all the same material. Here's another one, 5 different sized cylinders, all the same material. Again, all the same material. And we've got quite a few. So different sizes. So you've got a small one, you've got kind of a medium size, gradually they get a little bit bigger, but they're the same material in the tube. So this one is all the same material. Okay, so I just grabbed one for our example. So there's 1, 2, 3, and 4. Okay. All right. So the first thing that we're going to do is we're going to mass these. All right, so we're going to use this massing scale. Turn it on. Make sure we're set at 0 grams. Okay. All right, bring it up a little bit. You guys can see that. Yeah. Well, it does say 0 grams. I don't know if you can get that there. Yeah, you kind of see the 0 right there. Okay, so we're going to start with, I'm going to go in order, and here are the 4 different sized cylinders. Okay, so let's start with the smallest one. Okay, so I'm going to place it onto the massing scale, and that is 4.8 grams. 4.8. So in your interactive notebook, we're going to write 4.8. Okay? So this is cylinder 1. Okay? All right, we'll take that off. We're going to do the mass of the second one. Make sure it's at 0. And we'll mass this one. It is 7.7. 7.7. You might have to take my word for it. 7.7. Okay. Third one is 10.8. 10.8. So we're writing that into the notebook. And the final one, its mass is 13.6. 13.6. Okay. Now, on your interactive notebook, you have 5 cylinders. This set only has 4. Okay. So we're only going to be massing and doing the volume and figuring out the density for 4 cylinders. Some sets have 5. So I've included the 5th row just for any teachers who have sets that might have 5. Okay? But we only have 4, so don't worry about that 5th row. This would be Mrs. Wagner's room. Okay? All right. For the volume, we're going to be doing the water displacement. We do not need the massing scale anymore. Okay? So we're going to turn that off. And I'm going to set it aside. Massing scale is just for mass. This one is for volume. So we're going to be figuring out the volume of all of these little cylinders. Okay, So we know that we start with a certain amount of water. There's 25 milliliters in this graduated cylinder. And I will place the cylinder into the graduated cylinder, and then we'll see the water rise. We'll subtract that from the original amount, we'll subtract from the new amount, and then we'll get the volume of this cylinder. So we'll start with this small one. Okay. So I'm going to just carefully guide it in there. All right. And it's important that the whole thing gets submerged. And this is not, well, this one actually, a little bit. There's a little bit sticking up. So I'm going to submerge it with a pencil. Make sure I don't get the pencil in as well. And it looks like this is taking up 30 mil. Okay, the water has risen up to 30. Okay, so 30 minus 25 is 5. So that is the volume of the first cylinder, 5 milliliters. Okay, so the first cylinder has a mass of 4.8 and a volume of 5. Okay. All right. Now I'm going to dump out the graduated cylinder in the water, and then I have to refill the graduated cylinder with 25 milliliters, and then we'll do the second one. All right, so I filled it up again with 25 milliliters. This time I'm doing the second size in the tube. We'll drop it down. Okay, and as you can see, it just doesn't, there's a little bit of the top that's not submerged, so I again have to kind of press it down and make sure it gets in there. Okay, so each one of these little increments is 1 milliliter, and it has risen from 25 to 33, so that is 8 milliliters. So 33 is what it went up to. So 33 minus 25 is 8. All right, so the second cylinder's milliliter, its volume is 8 milliliters. All right, we'll do the third one now. All right, so now we are going to do the third size in the collection. I'm at 25 milliliters of water. We're going to drop this in, and my guess is it's not going to quite sink. Nope, same thing. So I'm going to press it down just a tad, and this time we have gone up to 36 milliliters. So what is 36 minus 25? It is 11. All right, so 11 milliliters is the volume of our third one. Maybe you can make a prediction on what the last one's volume is going to be. All right, final cylinder, dropping it in and pushing it down. And it is 39. Okay, so what's 39 minus 25? 14. Is that what you predicted? All right, so here's the data table. I'm going to make this a little bit darker. Some of these didn't get shown very well. There we go. Maybe that's a bit better. Okay. So we have the mass of all of these cylinders. We have the volume of all of the cylinders. Now we're going to figure out the density. Okay. So I'm going to help you with the first one, and then you've got to figure out the density of all of the rest. Okay. Our formula for density is mass divided by volume. Oops, there we go. As you can see back there over my shoulder. Mass divided by volume. I always think of, to try to remember the formula, is it mass over volume or is it volume over mass? I always remember a heart. It kind of looks like a heart, M over V. So the top part of the heart is the M, the bottom part of the heart is the V, line is in the middle, M over V is a heart, okay? So that's how we kind of can remember the volume of, or I'm sorry, the density formula for figuring out density of an object. Okay, so we have our very first cylinder. The smallest one is 4.8 divided by 5. 4.8 divided by 5 gives us a density. Now remember I said it didn't quite sink, and it wasn't really quite floating. This makes sense, being 0.96. So our density is it's not quite 1, 0.96 grams per milliliter. Okay? 0.96 grams per milliliter. Water has a density of 1. So anything above a 1 will sink. Anything below a 1 will float. And this hovers at the top. Not quite floating, but not really sinking all the way to the bottom either. Okay? And none of them did that. So this kind of makes sense, being so close to 1 that it's not really floating and it's not really sinking either. Okay? All right, so you're going to figure out the densities of the rest, and then we'll talk about our results.